Hello everyone, welcome to the another video on Wireshark Labs. Today we are going to talk about ICMP. Then what is ICMP? ICMP stands for Internet Control Message Protocol. It is a network layer protocol that is used to send error messages and operational information about network conditions. It is an integral part of the Internet Protocol suite and is used by network devices such as routers to communicate error messages or the other information about network conditions back to the source of the packet. In this lab, we will explore several aspects of the ICMP protocol. First, ICMP messages generating by the pinch program. What is pinch? Pinch is a utility that sends ICMP Echo Request messages to a destination host and waits for ICMP Echo Reply messages. It's commonly used to test network connectivity. So basically, it is used to test the network connectivity. Second, ICMP messages generated by the Traceroute program. What is Traceroute? So Traceroute is a Traceroute is a diagnostic tool used to trace the route that packets take from the source to the destination. It works by sending packets with increasingly larger time to live, that is TTL values, and examining the ICMP time exceeded messages returned by intermediate routers. The third point is the format and the contents of the ICMP message. So the basic format includes a type field and the code field, both of which provide information about the purpose of the message. So here ICMP messages do not have the numbers. Instead, they have the type field and the code field, which provide some of the information about the message. Here was the basic about the ICMP. Now we are going to download this zip file using this link and open the file ICMP ethereal trace 1. I have already downloaded the zip file. Here I have opened the Wireshark. Now here I am going to open that file. So this is my file ICMP ethereal trace 1. I am going to open this. So it is opened now. Now we have to answer few of the questions. What is the IP address of your host? What is the IP address of the destination host? Your host means we have to find the source and the destination IP addresses. So we will open our Wireshark. We can see here ICMP. We do not have to see the ARP packets. Instead, we have to see the ICMP. For better understanding or there should not be any confusion, we can also provide the ICMP filter. So here it is. So the source IP address is 192.168.1.101 and the destination IP address is 143.89.14.34. You can also see it from here. The next question says that why is it that an ICMP packet does not have any source and destination port numbers? At the starting, I already told you that the source and destination port numbers are not available in ICMP packet. Instead, there is type field and the code field. I'll show you here. See, in the ICMP, you can see the type is 8 and the code is 0. There are no such packets. There are no such ports. So, why is it so? Because ICMP packets do not use port numbers because they operate at a layer below the transport layer where the ports are utilized. Only the transport layer protocols utilizes the port, and this is not in the transport layer protocol, so it does not require the port numbers. Next question, that is the third question. Examine one of the ping request packets sent by your host. What are the ICMP type and code numbers? What other fields does this ICMP packet have? How many bytes are the checksum, sequence number, and identifier fields? So, one by one, we are going to explore each of the answers. First, we need to examine the ping request packet. So here you can see the arrow. This is the request. You can also see here ping request. This is the reply of that request. So we are going to examine this. This is the packet number 3. The time is 0.001653. The source IP address is this, which is 192.168.1.100, and the destination IP is 143.89.14.34. The protocol is ICMP, we have already known it, and the length is 74. Information. Other information is echo ping request. Its ID is 0x0200. The sequence number is 26369 slash 359. The TTL was time to live is 128. So here in bracket it is given reply in 4, which means the packet number 4. The request is sent in the packet number 3 and the reply is in packet number 4. So this is the hint for us. Now we have examined the ping request packet. Now, what are the ICMP type and code numbers? So here it is. The type is 8 and the code is 0. Now, what are the other fields does this ICMP packets have? How many bytes are the checksum, sequence number, and identifier fields? We need to find the checksum. So here it is. The checksum is 0xe45a. The checksum status is good. The identifier is 152 bytes and the identifier LE is 2 bytes. The sequence number BE is 26369 and the sequence number LE is 359. These are the values in the hexadecimal. Moving towards the next question, the fourth question. Examine the corresponding ping reply message. In above question, we have seen the ping request message. Now we have to see the ping reply message. What are the ICMP type and code numbers? What are the other fields does this ICMP packet have? How many bytes are the checksum, sequence number, and identifier fields? So here is our ping request packet. First of all, we will examine it. This is the packet number 4. The time is 0.415098 and the source IP address is 143.89.14.34. The destination IP address is 192.168.1.101. The protocol is ICMP. Length is 74. The message type is ping reply. Its ID is 0x0200. The sequence number is 26369 slash slash 359 TTL, that is time to live, is 231. The request in 3, which is the packet number 3. The reply is sent to the packet number 3. We are done with the first part. The next part is ICMP and the trace route. For this, we need to open the another file, that is ICMP Ethereal Trace 2. So here I have opened my Wireshark. You can see ICMP Ethereal Trace 2. I am opening this file in my Wireshark. So the file is opened. Now, we need to answer few of the questions given. What is the IP address of your host? What is the IP address of the target destination host? We need to find the source and destination IP addresses. So the source IP address here is, see the first packet, 192.168.1.101, and the destination IP address is 138.696.146.2. Sixth question. If ICMP sent UDP packets instead, would the IP protocol number still be 01 for the probe packets? If not, then what would it be? So, the answer for this question is, if ICMP sent UDP packets instead of ICMP, the IP protocol number would be different. ICMP uses protocol number 1, while UDP uses protocol number 17. In hexadecimal, 17 is 0x11. So the IP protocol number for the UDP packets would be 17, and in hexadecimal 0x11. Now the seventh question. Examine the ICMP echo packet in your screenshot. In this, is this different from the ICMP ping query packets in the first half of this lab? If yes, how? ICMP echo packets means nothing but the reply and the request packets, and ICMP error packets are the packets which contains the time to live exceeded. These packets are the error, which you can see in the black color. These are the error packets, and rest the request and the reply packets. These are the request and the reply packet, and in between also you can see the request packets. These are nothing but the ICMP echo packets. Okay, so it is asked whether they are different or same. So let's examine them. We can see our first packet. The time is given in both the packets. Source is given, destination is given, protocol length is given. This is the ID, sequence number, TTL, everything is given. But here there is no such things. If we examine the error packet of ICMP, we can see that its type is 11, that is time to live exceeded. Whereas in the echo packet, that is the request packet, if we will see, the type is 8. So the only difference is of type. Now examine the ICMP error packet In your screenshot, it has more fields than the echo packet. What is included in those fields? Again, we need to compare both of the packets. We have to see the echo packets, all the entries in the echo packets. It has type, code, checksum, identifier, sequence number. Here, it is type, code, checksum, and unused. Here we were having identifier and the sequence number, whereas here we are having unused. The value is 00000000. So this is the extra field provided in this ICMP error packet. Now the 10th question. Examine the last three ICMP packets received by the source host. How are these packets different from the ICMP error packets, and why are they different? We need to examine the last three ICMP packets received by the source host. Received by the source host. What is the meaning of this? First, we will go at the end. So, received means we have to find the reply packets. Ping reply packets are here. This one, and then this one. So for three of them, the type is 0. Type 0. Reply type 0. Reply type 0. How are these packets different from the ICMP error packets? I have already told you that for the reply packets, the type is 0, whereas for the error packet, the type is 11. So you can see it from here, the type number is different for both of the packets. Okay, coming towards the next question. Within the traceroute measurement, is there a link whose delay is significantly longer than the others? Refer to the screenshot in figure 4. Is there a link whose delay is significant longer than the others? On the basis of other routers, name. Can you guess the location of two routers on the end of this link? So first of all, we will go to the figure 4 in this document. Here it is. I'll zoom it for you. We need to run this command traceroute in our command prompt. Suppose I am giving www.google.in. So it is tracing the route. It will give you 30 hops. We need to wait for some time until it is loaded. Our trace is completed. You can see it here. So we need to examine which has the delays in them. We need to compare it. According to our data, the maximum delay is in the packet 12. And also in the packet number 4. So the answer is packet 4 and 12. You might get another answer in your PC. So here we have completed all the questions, and this was about this video. Thanks for watching.